In this video we are going to discuss about the entire chapter of polynomial. At the end of this video we came to know about polynomials, degree, zeros, relationship between zeros and coefficients. Question is that what is a polynomial? We learned in an earlier class that it is an algebraic expression which includes variables, constants and coefficients, but condition is that the power of the variable should be non-negative integers. Means, see, polynomial are generally denoted by p of x. If I take a polynomial as 2x square plus 3x plus 4, observe in this algebraic expression we have constant, right? These x as a variable and these 2 as a coefficient of x square, 3 is a coefficient of x. This polynomial this algebraic expression includes variable, constant and coefficient. That type of algebraic expressions are said to be a polynomial. One more thing you need to observe here, the power of the variable is here it is 2, here it is 1. It means both are the positive integers. If I take an algebraic expression as 1 by x plus 1, is it polynomial? No, because if I take this to the numerator, it becomes x plus 1 to the power of minus 1. See here, the power of the variable becoming negative integer, so that it is not a polynomial. This is very important. No, it should be a non-negative integer. If I take one more example as 1 by 2x square plus 3x plus 5. Is it a polynomial? No. Again, if I take this to the numerator, it becomes the power as minus 1. If I consider square root of x plus 2, is it a polynomial? Again not, because here the variable is x. The power of the variable is not a integer. Here it is a fraction, so that it is not a polynomial again. What about this square root 2 x plus 1? Is it a polynomial? Yes, it is a polynomial, because here it satisfies all the condition for definition of polynomial. Here it has the power of the variable is positive integer, right? So that it is a, we need not talk here about the coefficients. We need to know only about the power of the variable. It's satisfied, so that it is a polynomial. Understood? Next is before knowing two types, we need to know what is the degree of a polynomial. Degree is nothing but the highest power of the variable in that polynomial. If I take polynomial as 5x square plus 3x, what is the highest degree in this polynomial? I mean highest power of the variable. Degree is nothing but highest power of the variable in this case is 2. That is degree is 2. If I take polynomial as x cube minus 5x square plus x, what is the degree in this case? That is highest power of variable is 3, right? So that it is degree is 3 in this case. If I take as 2x plus 3 as a polynomial, in this case degree is 1, right? Based on the degree, we have 3 types of polynomial generally. That is linear, quadratic, cubic. Linear means degree should be 1. If degree of the polynomial is 1, then it is said to be a linear polynomial. If degree is 2, then it is quadratic. Quadrate means a square. If cubic means the degree should be 3. Right? So here in this case, here degree 2 means it is a quadratic polynomial. Clear? If degree 3 means it is cubic. If 1 means it is linear polynomial. Similarly, we have general formula for cubic, quadratic and linear. First general formula for linear is ax plus b. For cubic it is ax cube plus bx square plus cx plus d. It is a general form for cubic polynomial. For quadratic, it is ax square plus bx plus c. It is in the form of quadratic polynomial is always in the form of ax square plus bx plus c. Understood? Here we don't have constant, we can add 0 as a constant. Clear? These are the types of the polynomial. Next is a 0 of a polynomial. What is the zeros of a polynomial? Zeros of a polynomial is nothing but value of x that make the polynomial equal to 0. That is, if I have a polynomial as x square minus 3x minus 4, right? If I take particularly as x value, then if it is becoming 0, the value of the polynomial becoming 0 means then those value of x is said to be a zeros of a polynomial. If I take x as 1, then what happens? Replace x as 1, then which is 1 square minus 3 1 minus 4. It is 1 minus 3 minus 4. The value is 1 minus 7, which is equal to minus 6. Is it equal to 0? Not, it is not equal to 0. If I replace x as minus 1, then what happens? That is minus 1 to the power of square minus 3 into minus 1 minus 4, which is equal to 1 plus 3 minus 4, which is equal to 4 minus 4 equal to 0. See, in this case, when we substitute x as minus 1, the value of the polynomial becoming 0. If I take x as a 2, then what happens? P of 2 equal to 2 to the power of square minus 3 into 2 minus 4, which is equal to 4 minus 6 minus 4, which is equal to 4 minus 10, which is equal to minus 6, which is not equal to 0, right? If I take P as, x as 4, then what happens? P of 4 equal to 4 square minus 3 into 4 minus 4, which is equal to 16 minus 12 minus 4, which is again equal to 16 minus 16 equal to 0. Observe, in these three cases, the value of whole polynomial becoming 0 in only of x equal to minus 1 and x equal to 4. These particular values of x are said to be zeros of polynomial. That is, x equal to 4 and x equal to minus 1 are zeros of the polynomial, given polynomial. Understood? This is about zeros of a polynomial. Next is graphical meaning of zeros. Let me see how do we represent zeros in graphical method, right? That is, zeros are x-intercept of the graph. Let me take an example as linear. We know that the graph of y equal to ax plus b is always a straight line, right? It gives a straight line as a graph. So here, if I take an example as 2x plus 3, it is a linear polynomial, right? If you need to find the zeros of this polynomial, it means the value of this becomes 0. Then only the value of x is said to be a 0 of a polynomial. So by solving this, we get 2x equal to minus 3, x equal to, that is, I am sending this 3 to the RHS, it becomes minus 3, and x equal to minus 3 by 2. When we substitute x as minus 3 by 2 in this polynomial, the value becomes 0. Verify here, 2 into minus 3 by 2 plus 3, which is equal to, this to get cancelled, minus 3 plus 3 equal to 0, right? The 0 is x equal to minus 3 by 2 is the 0 of the given polynomial 2x plus 3, right? This is algebraically we find this. When we come to graphically, let me make a table, x here, y here. Y is what? 2x plus 3, right? When I take x as minus 2, substitute the value of x as minus 2 in this, we get 2x plus 3 equal to 2 minus 2 plus 3, which is equal to minus 4 plus 3, which is equal to minus 1. Right? When x equal to 2, it becomes 2x plus 3, which is equal to 2 into 2 plus 3, which implies 4 plus 3 equal to 7. Right? When I plot this in a graph, what happens? I'll take here. This is a graph, x versus here we have 0. A table is that this is x and this is y equal to 2x plus 3. This is minus 2, and when we taken only minus 2 and 2, when x equal to minus 2, we got the value of polynomial as minus 1. When x equal to 2, it has 7. Okay, so x travels from 1, 2, 3, 4, 5, so on. Here we have minus 1, minus 2, minus 3, so on up to, it continues like that. In the below we have this. Again, what happened? Here it is 1, 2, 3, 4, 5, 6, 7. Here minus 1, minus 2, minus 3, minus 4. Okay, when x equal to minus 2, where it is x equal to minus 2, the value of y is minus 1, that is here. This is when x equal to minus 2, then x equal to y becomes minus 1. Here the coordinate of these are minus 2, minus 1. When x equal to 2, y becomes 7. Here it is approximately 2, 7. Right? When we join these two coordinates, we get straight line as a graph. Right? Here we see this graph. This is a graph of 2x plus 3. It is intersecting the x-axis in the here. It is approximately between minus 2 and minus 1. That is minus 3 by 2 comma 0. That is the value of this is minus 1.5. The middle of minus 1 and minus 2. Here y is a 0. So graphically we can represent zeros of a graph is, this is the zero of polynomial is that the coordinate of x coordinate of the point where graph intersect the x-axis, that is a 0 of a polynomial. Understood? Here also we got minus 3 by 2. Graphically also we got minus 3 by 2. Clear? Here we need to know about relationship for quadratics. First we need to know the for linear polynomial. General formula for linear polynomial is ax plus b. If this value of the polynomial becomes 0, means the value of x should be minus b by a. When x is minus b by a, the value of linear polynomial becomes 0. This is a relationship between the coefficients and the zeros, we can say. Here minus b is what? That is constant in this. That is constant term. Minus constant divided by a is what? Coefficient of x. Coefficient of x. Right? This is for linear. When we talk about quadratic, that is ax square plus bx plus c equal to 0, then sum of zeros. Here sum of 0 is, let's take alpha and beta are zeros of p of x, I mean this polynomial, then sum of 0 become minus b by a and product of zeros become c by a. These are the two formulas you need to keep in our mind. Okay, let me verify by taking an example. Here this is an quadratic polynomial because degree of this polynomial is 2 and the given sum is 5 and product is 6. We have formula that sum of zeros is minus b by a and product is c by a. Let me verify here. Sum is 5 they given, that is alpha beta equal to 5, that is minus b by a. Sum means alpha plus beta minus b by a. Here compare this with the general formula, that is ax square plus bx plus c. Here minus as it is, b is what here? 5 and a is 1 in this case. So here it is minus 5, right? Sum is 5. Here we have value of b is minus 5, already minus is there, minus of minus 5, it becomes plus 5. Okay, here whatever they have given we got that by using this formula. Again for product of zeros we have c by a. C means the constant term is 6. A means again the coefficient of x square, that is 1, which is equal to 6. We got 6. Understood? Yes. Here we have one question. Find zeros and verify relationship. That is relationship means sum of zeros and product of zeros, that is alpha plus beta equal to minus b by a and alpha beta equal to c by a. We need to verify by these. But we need to find out alpha and beta in this case. Alpha beta are the zeros, right? How do we find zeros of a quadratic polynomial? What we need to do? How do we do? Generally we split the middle term, right? 7x. Take 7x, by splitting 7x we will find the zeros of this polynomial. So for that, take this 10, choose two factors such that their product should be again plus 10. When we add those, we need to get 7x again. Okay, two factors are, what are those factors? That is 5 2s are 10. By adding these two we get 7 and again multiplying these two we get plus 10, right? So we write 7x as 5x plus 2x plus 10, right? Which becomes, take x from these two as common, we remain with x plus 5 plus, in this case take 2 as a common, we left out with x plus 5 again. So here x plus 5 as a common. So this x plus 2 we write in a 1. So we are finding zeros. Equate this to 0. Right? So that is x plus 5 equal to 0. One more, x plus 2 equal to 0. That is x equal to minus 5. X equal to minus 2. These are the two zeros of this polynomial. Understood? This is by finding the zeros of polynomial by splitting the middle term. We have so many methods to find the zeros of a polynomial. We can use that quadratic formula as x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. We can use this formula also, or we can do by splitting the middle term. Understood? Here we need to verify by using these two relationships, that is product of zeros and sum of zeros. Here sum of zeros becomes, that is minus 5 minus 2 becomes minus 7. That is what? Minus b by a. Here minus b is what? Minus as it is, b is a 7 and a is a 1. See here we got minus 7. Understood? This is a verification. Again, product of 0 is minus 5 into minus 2, which is equal to plus 10. So the formula for this is C by A. C is what here? Plus 10. A is again 1, which is equal to 10. Understood? C. 10 and minus 7. These are the sum and the product of these two, the given polynomial, right? This is a verification. Yes, student, this is about the today class. I hope you understood well. Please don't forget to subscribe and like. Thank you.